telephone number? Do I need to store it with your insurance information? Yeah. What about your tax information when we withhold and pay taxes? Yeah, probably there too. And what about with your initial employee application? Yeah, we need to probably store it there too. Here's the problem. I could have lots of different data files that go to different purposes that need to have your address information. Why should I have that replicated individually, freestanding on each instance? Because then I'm open to, sometimes maybe we updated this file but not that file, and now you've got addresses that don't match. Why don't we just have all of them refer to the one source where we keep your information? And so, again, I don't actually have the data in those different locations, but they know where to get it from, and there's only one version of it. This is where we are using what we call normalization to ensure that we maintain consistency. Well, here's the problem, though. Referential integrity. What happens if I deleted that address information from where it was supposed to be, and now I've got all these other files saying, get the information for Alan's address from there, but it doesn't exist? That is a break of referential integrity, meaning there's a referral there, a linked table, but linking to a deleted or obsolete or rather missing record. So we would have a breach of referential integrity. ISACA is concerned about that, and we need to know that we would use referential integrity checking to find that issue. Data warehousing fundamentals, you're just going to need to know some terms and definitions here, knowing the difference between data warehousing and data mining, for example. So data warehousing, combining data from multiple databases into a large database, and then you could then mine that data to come up with other new correlations and metadata. So, and then there are certain concerns with data warehousing that ISACA has that may come out in your exam. And I give you examples of that here. Wink, wink, nod, nod. So that, in other words, you need to memorize those things in case you run across a similar question. Data mining as compared to data warehousing. Like I said, we warehouse the data here so that way we can, manipulate it and massage it to try to determine trends and anomalies and things like this using data mining techniques. That's the process on the data that we store in a data warehouse. And then there are examples that are exam-y examples that I give you on this slide that you'll need to memorize for your exam preparation. Data warehousing fundamentals, again, we're concerned about if the data maintained in a warehouse can only be as good as, well, how much we trust where we got it from. So the quality of data in a data warehouse is determined by the data source credibility to begin with. And so ISACA has other concerns that you're supposed to know for your exam preparation, making sure that if you have that much data in one place, that you have appropriate access controls. ISACA also wants you to know about a decision support system, a DSS. This is what we use with data warehousing and data mining to try to have better decisions. Again, if you analyze more information in a very structured and thorough way, you might come up with better decisions. It's a decision support system. ISACA says this is what we'll use to support semi-structured decision-making tasks. And you will know that's a decision support system. Again, it's semi-structured, which means less structured problems using a semi-structured decision-making task, again, that doesn't have fixed criteria. We have something besides a DSS, something known as an expert system. An expert system emulates artificial intelligence. Again, a whole lot of if-then type ideas acquired from human subject matter experts. We almost kind of use these in real life when you go into the doctor's office and they start asking you questions. Basically, it's a logic tree. If your stomach hurts on this side but not that side, that's going to rule out issues here, and it's going to make us focus on issues there. And let's ask some more questions. It's a decision tree. Expert systems can help in that kind of way as well. When auditing an expert system that manages credit limits for a financial institution, what should be concerned with? ISACA says the level of experience and skills that are contained in that knowledge base, meaning your expert system is only as good as the experts that gave it opinions to work with. Yes, you will have, to this day, some EDI questions, electronic data interchange questions. The main questions you will be getting are just some of the formal definitions in terms of various components. So again, what is EDI? Electronic data interchange, electronic transmissions of transactions between two organizations. Early on, we had to come up with a standard for different systems to communicate transactions and other types of data. They need to be basically communicating in the same structure, in the same form. So we came up with a standard for it, electronic data interchange, or EDI standards. It allowed disparate systems to communicate properly. Again, it's something that we take for granted now, but this was something that we had to worry about early on. Again, the advantage of it was it promoted a more efficient paperless environment, can replace the use of standard documents such as invoice and purchasing documents. Again, you'll need to know for your exam the difference between a communications handler and an EDI and the EDI interface, which does which. In my practice exams that you do, if you run into a question related to this, instead of giving you multiple choice questions that still leave you not really grasping it fully, I went ahead and gave you matching questions. So that way you have all of the definitions on one side, all of the terms on the other side, and you have to drop and drag the appropriate one to the appropriate term. And that allows you to get it straight in your mind, which is which, and then it'll keep you straight on your exam. Again, the questions I built were there to teach, not just confuse you. So you'll need to know that an EDI translator is what translates data between the standard format and a trading partner's proprietary format. An application interface is what moves electronic transactions to or from the application system and does the data mapping. The application system is, those are the programs that process the data sent and received. And then within EDI, we have transaction authorization tends to be the greatest potential risk in an EDI environment, because originally the idea was if these two systems are even connected and talking over their dedicated line, then we're just going to assume that everything they're communicating is real and valid and authorized, because there could be no potential false communication, because they wouldn't even be connected. This is back when we hardwired systems from one to the next. And so because of that, EDI originally didn't have much authorization of actual and checks of information transfer and processing. It just assumed that everything was good because, well, it has to be, because otherwise we wouldn't be connected and talking. Again, you'll need to know this for exam preparation purposes. This means that EDI reduces opportunities for review and authorization because it's simply not tracking it. It's assuming that if we're connected, we must be good. Again, necessary communication protocols. Again, we have to agree upon the same communication protocol between our two systems for EDI. Mapping is what identifies specific program logic that has not been tested. Functional acknowledgments are used to provide efficient data mapping. Again, a lot of terms and definitions that you'll need to memorize. Practice exams will help with that quite a bit. Electronic data interchange controls, again, what do we use to help us validate data and transaction integrity? We'll use checksums. We talked about that before. Batch balancing is what verifies output results and control totals, matching them against input data and control totals, batch balancing. Looking at enterprise resource planning systems, verifying production orders to customer orders within ERP helps us ensure that orders are entered accurately and corresponding products are produced. Again, we've left EDI now, and now we're looking at ERP systems. You may still get some questions on that to this day. Web applications. That's right. Once upon a time, ISACA even asked us about applets, Java applets and things like this. Now you think about plugins and so on, improving the performance of a web server and network. Again, that's going to pretty old technology, but it may still be on your test. Hard to say. You'd be amazed at how many old things stick on this exam throughout successive revisions. I'm a bit surprised, but it's true. Again, what is used as a good way for transferring data between an application and back to the user? That's a CGI interface. Alan, tell me more about that. I don't understand CGI interface. This isn't that level of a technical exam. You don't need to know it that deeply. You just need to know that whatever CGI is, that's what we use as a consistent way for transferring data to the application program and back to the user. That is enough for your test, and that's what I'm teaching you. But I'm just going to have to memorize it and regurgitate it, and I won't even necessarily be knowledgeable. Knowledge takes a long time, and that takes a lot of work. This course is about, again, just trying to get you to where you can pass as quickly as possible, and that's what that's about. This is going to require a lot of rote memorization. Open systems architecture. It facilitates interoperability within different systems. That's open systems. Web services are what give us efficient exchange of information between two systems. Really? That's a formal term, web services? On ISACA's exam it is, so be prepared. The SDLC, sometimes called the software development lifecycle, sometimes often called the systems development lifecycle, even though they are very different things. Here is the first thing I would give you a heads up about. If you already know some ideas about SDLC, perhaps because you practice it or because you had to study it for another exam, there are different versions of the SDLC out there. And which one does ISACA test you on? Well, that's why you're here. I'll show you what their interpretation is, the phases that they feel exist, and what is in each phase. So exercising quality management techniques continuously throughout a project reduces costs by doing what? Maximizing the defect detection rate. So again, this is we look at our SDLC. ISACA, again, it's kind of weird because they also address SDLC on the CISM exam and on the C-RISC exam as well. And I found out because different exams have different updates, they've actually become to have different versions of these SDLC phases across their own exams. Welcome to my world. I have to keep track of all of this. So for this exam, you have phase 1, feasibility. On other exams, they call it the initiation phase or the planning phase. But on this exam, maybe the feasibility phase. Phase 2, we have requirements. Phase 3, the design. Phase 4, the development. Phase 5, implementation. And then finally, phase 6, post-implementation. Again, if you've got a different understanding of it, but that can't be right, I studied it. Remember, there are different versions of this out there. So you're bound to run into that kind of conflict. These slides are going to go now to, rather than trying to tear apart the whole SDLC, again, I'm just giving you exam-y stuff to understand when it comes to what you do in each phase of it. So in phase 1, feasibility, this is where we align our corporate goals and objectives. We're trying to fulfill requirements. That's why sometimes we hear it called the feasibility phase, the requirements definition phase, the initiation phase. The dominating consideration is making sure that we properly are planning to fulfill the requirements of the organization, so we better learn about and establish those requirements up front in the feasibility. Again, should we already be considering security requirements in feasibility? If we need security in order to comply with law later, then yeah, we should start thinking about it right there in the feasibility phase, rather than completing half the project only to determine we'll never get this thing compliant. We can't operate this way. So again, we're going to start thinking about security as early on as possible, right up front in the feasibility phase. This is where we develop our business case. We talked about business cases earlier, remember? Phase 2, requirements phase. Again, it's pretty self-explanatory, determining the business requirements based upon business owners' needs. This is why we need to have early engagement of those systems owners to make sure that we well understand their needs first before trying to build a system to meet the needs. Know your requirements first, then create the application and the systems to fulfill those needs. And we get those needs from the key users, the systems owners themselves. Phase 3 in the design phase, this includes program database specifications. This is where we would have determined feasibility requirements back in the feasibility stage, and now we have to consider those security requirements in the design phase. The idea is to build security in rather than layer it on later. So ISACA has feelings that if you let business units determine development of applications, they're going to forego any security considerations because it's cheaper, faster, and easier. That's their feeling. Change control processes help prevent requirement scope creep and so on. Again, procedures to prevent scope creep are baselined in this design phase. In the design phase, this is where we put our input-output definitions. Again, this is going into programming and systems interoperability requirements. Data file, database systems determine and how those are going to work, the program specifications, and so on. We don't necessarily perform testing in design, but we do plan for the testing later. So that would mean that testing is first addressed in the design phase, not just in the development phase. We plan for tests before we implement tests. Interesting. That would be a tricky question, wouldn't it? Yep. Data conversion is planned even if it's not performed in the design phase. Also in the design phase, we'll use software baselining. Again, there's examples of what you might have with software baselining. Phase 4, development. This is, again, done by the programmers and the systems analysts themselves. This is where we're developing the systems. Again, examine things you need to remember. Poor programming coding practices result in vulnerability of a buffer overflow exploitation. You don't need to get into the technicalities of how that works. That's a whole 15-minute, 20-minute discussion at a bare minimum. But the idea is that if you end up having processes that essentially go beyond the capabilities of the system to store and consider data, then you can end up having that exploited. This is a way to kind of soft crash a system and get around security measures at a hardware level. Moving along, we have an IS auditor's primary concern when applications developers wish to use historic transaction files is that if you're using true historic files, that may have sensitive information those coders don't need access to. We also talk about segregation of functions within developing software, testing software, and actually deploying and using software. This is what we use separating our development and testing and our software libraries. Library control software is what ensures that we only have authorized exchange between those segregated functions within our development. Again, examining stuff to memorize for software development testing. Phase 4, we get into, again, testing within the development that we planned back in the design phase. We have bottom-up testing. This is where we're testing little individual granular components. I've created a process that opens a file. Well, before we do anything else, let's see if it really opens a file. Okay, that's bottom-up testing. As opposed to top-down testing, I'm going to say, hey, look, are we going to be able to have this system interface with your system? And let's go ahead and figure out what it takes to even talk at that level before we get down into how to open files with systems. So again, we can do bottom-up testing, or we can start with systems testing where we're actually not really testing systems for real, but we might be testing basically mock-ups of systems to see if, for example, our users will even be able to understand the screens, for example. So bottom-up testing is nice because the advantages, we can conduct it before all programs are complete, and we find errors in critical modules very early on. Top-down testing, again, is where I'm really looking for just general functionality and compatibility testing before I actually develop the components and modules that deliver that. So this tests major functions and processing early rather than the actual function of the executables themselves. This is where I find out that interface errors are detected earlier. And it could be an interface error between the user and the system itself. Again, this is what we use in prototyping. Again, development testing classifications. We have unit testing that's used for bottom-up testing. Again, user interface and interface integration testing. That's again more at a top-down level. Systems testing, making sure that all components work properly together, not just in isolation. You'll need to know the difference between white box testing and black box testing. White box versus black box, think of it in terms of transparency. If I'm able to actually, for example, if I can get a website to perform a certain function without really keeping track of the coding and the actual process and log entries of what was actually happening while it did something, if I just see, well, it seems to work because, well, I logged in and I was able to accomplish this task. I was able to configure a new article. Okay, great. Does that mean that there are no problems? Does that mean there are no errors? Not necessarily. I didn't really look at it at that level. I just looked at it I didn't really see inside to see how it was executing what it did. All I know is it seems to accomplish what I wanted it to accomplish. There's no transparency there. You're just seeing evidence that the result was correct, so you assume that it must be processing correctly. Since you can't see the internal logic, you're just seeing that the output came out okay. That's called black box testing because your view of how it's processing is obscured. You don't really see the code. You're just seeing the results of it, and that's black box. White box testing, this is where we actually are able to see what's happening and errors generated as processing occurs. This tests the actual program logic itself. Black